Hi guys, it's Miss Keen. I want to remind you to take out your green sheet to make notes during this recording. I'll also remind you that since this is a YouTube video, you may stop, you may rewind, you can pause this video. In my favorite, you can replay it over and over again until you understand the concept. So here we go. In case you'd like to follow along in your book, I am on page 31. It is actually the same thing that I have displayed right here on the screen. All right, in this investigation, there's going to be some words that you've probably never heard of before. One of those words is this, right here, Pythagorean. And the other word is hypotenuse. Let's see. We're going to talk also about something called legs. And you've probably heard of a leg before, but maybe not in a mathematical sense. All right, so this chapter is called the Pythagorean Theorem. We are going to finally discover what the Pythagorean Theorem is. We've been building and building step by step towards it. And the Pythagorean Theorem, I'm not going to tell you exactly what it is because it's fun to find it on your own. It involves right triangles. And before we get into it, I need to tell you about the different parts to a right triangle. You're familiar with this part right here where you put the square in the corner to indicate it's a right triangle. But each of the three sides of a right triangle also have names, as you can see here. The two sides that are off of the right the right angle, are called the legs. Okay, so each triangle has two legs and they are connected right here to your right angle. The side that's opposite the right angle is called a hypotenuse. It happens to be my favorite math word. So the hypotenuse is always going to be the longest side of your triangle, and it's always going to be straight across from your right angle. You'll see me do this a lot. You'll see me when I draw a right triangle, I will draw this arrow pointing to the longest side to indicate that that's the hypotenuse. All right, so these are the three parts of the triangle. Okay, so here we have just a right triangle right here. We've seen these many times on our dot paper. And what we've been doing is we've been finding the length of the line segments. Okay, and at the end of last week or the last investigation, we saw that sometimes these line segments are attached. And in this case they are, and they form a right triangle. And we've discovered ways to find the distance or the length of that line segment under two different methods. Well, first of all, let's see here. We have this right triangle, and we have been making squares off of our right triangle to find the length of that particular line segment. So I'm going to pop over here for a second. I'm going to talk about this line segment right here, which is congruent, or the same line segment on this display. And if I asked you to find the length of that line segment, first of all, because it's a horizontal or a vertical line, in this case a vertical line, you can count from one dot to the other, and this would be 1 unit in length. Our other method that we've discovered is we can make a square off of that line segment, find the area of that square, and then find the distance of that side. Okay, I'm going to show you that method right now. So if we're finding the area of this blue square, it is 1 unit by 1 unit, and the area formula for a square is side squared. Okay, so I have the area is going to be equal to 1 squared, which is just equal to 1. And I always say units squared because we always end our area in units squared. Okay, so that is, we'll call that leg 1, the area for leg 1. Okay, And then that's just the area. If I want to find the side length of that same leg 1, I take the square root of my area, which is the square root of 1, and that is the distance along this line segment and this line segment. But we know that the square root of 1 from our green sheet and the last investigation is equal to 1. So I will say that that line side length of leg 1 is 1 unit. Okay. Alrighty. Now, if I'm trying to find the length of this leg, and I'll call this leg 2 right here, I can do the same thing. Because this is a horizontal line, I can just count from 1 unit, or I can make the square off of the leg and determine the area of that square. Well, it's identical to this one here, so I'm going to say that's also 1 unit squared, which also means that the leg 2 has a side length of square root of 1 or just 1 unit. Okay, so I'll put that over there. All right, now you know from your experience that sometimes these diagonal lines are tricky. We know that a diagonal line from here to here is not 1 unit. It's only 1 unit when it's horizontal and vertical. A diagonal line from dot to dot is not 1 unit. So we have to use one of our other techniques to find the length of that green line. The length of that green line, which is over here on this one, and now we know the proper name for that green line. It's the hypotenuse of the triangle. Okay, so to find the length of that, we're going to make our square off of it, like so. Okay, but because all of these are diagonal lines, I can't say that it's 1, 1, 1, and 1. I have to find the distance from for each of these diagonal lines. And I do that in 2 ways. Do you remember what they are? That's right. You can either make the box around the square, or you can divide the square up into smaller right triangles or squares. In this case, I can make 4 smaller right triangles, so I'm going to use that method to determine the area of this square. Okay, now this is the hypotenuse. I'm going to I love that word, hypotenuse. I'm just going to abbreviate. Hypotenuse. Now, when I'm trying to find the area of a triangle, because these are 4 right triangles, the formula is base times height divided by 2. Okay, so I have base is 1, height is 1, so 1 times 1 divided by 2. 1 times 1 divided by 2 is a half. Or you guys like to use decimals, so I will use a decimal. There. Okay. Now I just found, I'm just going to change my pen color so it's easier to see. Okay, I have found that that is a half and this is identical. So that one's also a half and this one's also a half. And here we go, last one, half. So the area of the hypotenuse is equal to 1/2 plus a half is 1, plus another half is 1/2, plus another half is 2. So the area of that square is 2 units squared. Okay, but I don't really want the area. It's just my step to get to the point where I can find the distance of this side length, or the hypotenuse as we now know it. So the side length is equal to the square root of 2. Okay, so this is the square root of 2. Okay, now we are going to, in the next couple days, be making right triangles, and you're going to different size right triangles, and you're going to draw the squares off the sides as we have here. But eventually you're going to get to see a pattern, and that is the Pythagorean theorem. Now, when you recognize the pattern, you're not going to need to draw the squares anymore. You may if you want to, but there is the Pythagorean theorem is really a way to eliminate having to draw these three squares off the side. And hopefully we'll discover that very soon. Now I want to leave you with a question. And the question is, how are the areas of the three squares related? Okay, so I want you to think about this, and I believe this question is on your green sheet. Here we go. You're going to compare, let me get a different color. You're going to compare this square, the area of that square, the area of that square, and the area of that square. And answer this question down here, right down here. How are the areas of the three squares related? Okay, this is part of us recognizing the pattern so we can discover that Pythagorean theorem. All right, guys, see you soon. Replay it if you want to. Talk to you later.